In our last lab, we discovered that when you react two chemicals, you find that some of one or the other reactant is left over depending on the ratio of those reactants. This was exciting news for Joseph Proust. If you can have too much of one reactant or another, maybe you can find that perfect ratio of reactants so that neither's left over. So feeling more confident in his atomic theory and that he could defend the attacks of the atomic deniers and ultimately prove that everything in the universe is made of atoms, he boldly developed his theories even further, and he came up with 3 ideas or 3 tenets to his theory. So first, each chemical is made up of one type of molecule, and this molecule is defined by a specific ratio of atoms. So it could be a ratio of 2 to 1, or a ratio of 3 to 4, a ratio of 1 to 1. Chemicals that react to form a molecule will react in a specific ratio, leaving excess reactants if there's too much of one or the other that's going into the reaction. 3, if no reactants are left over, and this is where we're going in this lab, so if no reactants are left over after a reaction, you have found that perfect ratio. And actually, this is how you know the chemical formula of molecules. So point 1, just taking a step back and reviewing each of these 3 tenets. Point 1 means that only one of the following formulas of table salt is correct. So table salt cannot be all of these 3 formulas. It's either NaCl, it's either Na2Cl, or Na151Cl213. One of these is correct, but not all 3. For point 2, let's assume the correct chemical formula for table salt is NaCl, which it is. Then if you react 5 atoms of sodium with 3 atoms of chlorine, you have excess sodium, and so you have 2 atoms of sodium left over. The math there is actually kind of simple if you just take a look at it. And point 3 suggests a way for us to find what the chemical formula of a molecule is. For example, if you know 2 atoms of hydrogen react with 1 atom of oxygen, this is how we know the chemical formula of water is H2O, because it takes 2 atoms of hydrogen to react with 1 atom of oxygen. Can you use these ideas to find the perfect mass ratio of baking soda and vinegar such that neither is left over? So we won't be counting atoms and adding these atoms we count into a reaction. That would be impossible. But we can actually measure mass, and we can find the perfect mass ratio. So another way to say this is, another way to ask this question is, how many grams of baking soda react with how many grams of vinegar such that neither is left over? Can you find that mass ratio?